Hi, in this session we are going to discuss about simple RAG implementation or naive RAG. This is a demo part. We already discussed what is simple RAG. So this is a collab notebook. In this notebook we go step by step, like we are going to load a small data set. Just I want to explain how it has to how it will work, so that I'm taking only small data set here. So this is the data set I'm using. So this is a finance data set from Kaggle. Here there are you can see here it has a question and it has an answer and corresponding PDF content for that particular question. The pages from where it has been extracted and the link source, like actual PDF content. So that is a data set I'm taken here, and then we're going to do a step-by-step process. So we encode a particular column. So here we're going to use the PDF content as a column to encode because that contains the actual answer, and then encode into embeddings, and then retrieve some of the rows, like based upon the user query. We are going to retrieve some of the rows based on semantic similarity, augment both the content which has been retrieved along with the query, and give it to LLM to answer the question and generate the reply. And I will show a step-by-step process. So these two are like just for visual enrichment, so that it will be easily understandable visually in a color coded format. So now I am loading that particular data set. It has only I think 20 records in it. Yeah, 20 records in it. So I'm just loading that one. This is already a CSV file. You can download it and convert it to CSV. So now this is the display. So we have, what are the contents in that one? Like we have a question. I'm not doing anything AI related here. I'm just using pandas to display the content. So we have a question, and then we have an answer. So here the same thing, question, answer, and then the corresponding PDF content, and then pages, and then from where it has been read, like the actual PDF source. So this is just for our understanding how the data looks. So now this is the part where we are going to do the embeddings. So now we are going to embed only one particular column here. This is PDF content. So we are going to embed the PDF content as embeddings and store it in a vector database. There are different vector databases. Vector databases are specialized databases which hold vectors of the embeddings. So now I'm using a QDRANT, so in-memory database. So this is just for demo purpose, so I'm not going in anything fancy here. So initializing the client and then having QDRANT in-memory database, which can have it in the collab. To run these things, we don't need anything GPU based processors. We can only go with either CPU based, or FreeTILE you can have T4 as well. So this is an in-memory database. I'm installation that one, and then I am using all-MiniLM L6 V2. This is a Hugging Face sentence transformer used for creating embeddings. It's a small model and it's a robust model. So now I'm naming it the collection as finance Q&A. Just we need to name the collection, so that's why we, for each and every collection we can give different names. For this collection I'm giving as finance Q&A, and I'm creating the collection here. So I didn't mention any vector size here, so it depends, it is based upon the embedding model you choose. I will show you what is the vector size here. So now we are actually doing the embeddings or vectorizing it. Okay, we are going to vectorize only the PDF content here. So given the collection name, all those things, and then we are mentioning the column, like which column in that CSV we are going to convert into embeddings. So we are going to convert PDF content, this particular column, into embeddings. So it will iterate and then convert each and every record or the PDF content in each record into embeddings. This is a plain vanilla embedding, and you can see here this is the vector size. I'm just displaying. I just want to display what is the vector size, the collections here, like the metadata of those things. So here we are going to use we are using 384 dimension of that vector, and then cosine similar distance is cosine similarity. Okay, Don't worry about these things. These are highly technical. Now we have the document embedded and stored in a vector database. Okay. So now the user is asking a query. So based upon that query, we need to get the relevant documents. That is the main purpose here. Once we get the relevant documents, we pass it into LLM to generate the answer. Okay. So user prompt or user query is this: what is the comprehensive income attributable to 3M in the year 2018, and how does it compare to the previous 2 years? This is a simple straightforward user question. So now in order to get this question semantic search, of course in the backend it will be using that one. So we are going to convert this particular user prompt or user query into same type of embedding, and then only we can do the semantic search. So for that, first we need to do that one, and then get the similar rows. I'm limiting it to 3 records. Okay. So we are encoding it and then getting the similar rows for that particular encoded user query. This is just enriching the visual. So here you can see the retrieved results. Okay, so it retrieved 3 records. So what is the question asked? What was the comprehensive income attributable to 3M in the year 2018, and how does it compare to previous 2 years? See the first thing. So this is the most similar chunk it has been treated. So what was the comprehensive income attributable? So I just asked the same question which has been there in the data set. So first question maybe this one. I didn't change any wordings here. So it retrieved this chunk as a first first chunk, most relevant chunk, and rest are less relevant compared to the previous one. That is well and good, and we need to generate the reply. So we got the chunks, the context. Okay, we got the context here along with the user query. So we are going to augment. So we will augment the context and the user query and pass it to LLM, so that LLM can answer precisely what the user asked based upon the given context. Yeah. So now we will try the retrieval without any content given. So we already saw this is the content retrieved for the user query, but now we are going to ask the LLM without passing any of these contents. Okay, let us see how it behaves. So here I'm using OpenAI. So you can use any LLM, any generative large language model. It may be OpenAI, it may be from Anthropic Claude, or it may be Gemini. It's up to you. Or even if you have any privacy concerns, you can have your own generative model running on your own system or in hardware, and then you can use that one. For that you can use Olama. So now I'm using OpenAI. This is just for demo purposes. So for OpenAI, we need to have OpenAI key stored somewhere and then call it. In Colab there is a process like we can store it separately in an environment, and then you can call it this way. This is very easy and straightforward without exposing the keys. So now we are going to retrieve we are going to get the answer without passing any of this retrieved content. Let us see how it behaves. This is a process here. So here the completion here, how this is a stat completion model. Like I'm using GPT 3.5 Turbo. You can use any of the models. Like you can go for GPT 4.0 or 4.0 Mini, whatever it is. This is cost effective and it serves our purpose. So now these are the messages, like first role system. I'm giving the contact, and you are the chatbot, and you financial analyst. I'm specifying the role you have to take, like you are a financial analyst. So I'm specifying it here. So the main thing here is that you can predefine like what role it has to take. Either it may be a financial analyst, or it may be a legal analyst, something like that, or it may be a mortgage analyst. So you predefining so that it will scope to that thing, and then you give the answer. It will give the answer. And one more thing is that the prompt. So the prompt is more important here. So how you define the prompt, or how you ask or prompting the LLM to give the answers, that make a much of difference. That itself is a separate study. We call it as prompt engineering. So if you ask most relevant or most apt question, then you will get the most relevant answer. So that is one thing keep in mind. So prompting is a specialized field where the way you ask the answer and what are the expectations you have, so based upon that only you will get the answer. Okay, so that is a different thing we can discuss later, but here I'm just specifying the scope. You are a financial analyst and user prompt. Here user prompt is the question what I ask, like this is the question we already declared, and then here I'm not pausing any content of the retrieved documents, like we are not pausing any of things. This is without any retrieval. So yeah, I'm just giving you this is the analyst answer. So what how it begins, let us see. So now I'm asking the question here. This is just for styling. So answers without retrieval. So I ask, what is the question asked here? What was the comprehensive income attributable to 3M in year 2018, and how does it compare to the previous 2 years? Okay, now you can see this one. I don't know from where it got this, because this we can say this is a good example for hallucination. So you know that LLMs will hallucinate. Hallucinate means like it will give you a confident lie. That is called hallucination. Like, you know, confidently say this is answer, but it's a totally wrong answer. So this I don't know from where it got this. This may be somewhere in trained data, it is getting somewhere and then augmenting it and giving it to you. We all know that LLMs, especially these large language models, have a cutoff date. So until that date, whatever data it has been given for training, that will be there. Apart from that, it doesn't have. So in order to have our own data as a context, we are going for RAG. So now this is a classical hallucination example. It is since we already declared it's a financial analyst, it giving some random answer saying this is the correct one, but this is not actually correct. So now we are adding the retrieval results. So these are the three top retrieved results. Now we are adding these things to LLM and see how it answers. So now I'm defining the search results, and then this is just holding the search results. Here we already have the search results. Okay, this one. So yeah. Okay, so hits. So we already declared here, and then we got that one. These are the three top content chunks we need to answer the question based upon the user prompt. So then the same thing here. I just changed a little bit of prompting here, like you are a chatbot, an expert financial analyst, able to analyze a given financial details and provide concise answer to the user. So this you can elaborate, like how precise, how much you want, or if you want to do the calculation, you can give what are the calculation it has to do. All those things you can include here. So this is how you are dictating or we are instructing the given large language model such that it will produce the results. So you can give the processes like how it has to behave. So I just give a one line, expander line, and then user prompt. User prompt is the actual question, and then the search results. Okay, so these are the search results. I am giving it here. So now you can see here. This is just for styling. Answers with retrieval. So the same question asked with the content. Okay, the given context. The comprehensive income attributable to 3M is to 5,508 million. So you can see. Maybe from this one. Okay, we will go to the. So this represents increase in competitive. Okay, to 5,700 million, 2004 and 2016. The trend shows the positive growth. Okay, so now we can clearly see from this particular. So I given some. Yeah, okay. This is the one, right? Yeah, retail results. Okay. This is the text. Okay, you can see here. 5,508 million in the same this particular first chunk has been used to get the answer. Okay, So previously it doesn't use that one, but now it uses that particular given chunk and answer based upon that particular question. Okay. So now, even though it hallucinated here in the previous step, like in the previous question, without giving any content, now I asked a specific question without any retrieval, like what is the user prompt. I changed it. What is the company discussing the airlines on? Definitely it doesn't have any context regarding that one. So if you try without any retrieval, see, it gives an answer like, I'm sorry, I couldn't able to give specific information or the content about the earnings call, because it doesn't have, even though in the previous question it hallucinated, in the second question it clearly say it doesn't have any answer for that particular question. What is the question asked? What company discussed? What is the company discussing the earning call? Definitely it doesn't have anything. But now the same question asked with the content given, because I used the same search results. I didn't rerun the query to get the results, because if you can see in all the chunks it has 3M mentioned. So that's why without running the previous thing, I asked the same question here. It clearly see the company discussing the alien call is 3M company. So this clearly differentiates without giving a content what happens, and with the context you give, you will get the relevant answers from the content. So this is one main advantage, like why we go for RAG instead of using a plain LLM. So RAG, we see, like we use it for our getting the answer from our own documents or our own data. So this is of course a simple naive RAG. So in coming videos we will discuss like how we can improve this.